When most people hear the word desert, they picture endless sand dunes under a brutal sun. That image is real, but it is only one version of a much bigger story. A desert is defined not by sand, heat, or camels, but by scarcity of precipitation. It is a landscape where so little rain or snow falls that life has to operate under constant water pressure. Some deserts are scorching, while others are frozen. Some are covered in dunes, while others are flat fields of stone, salt, clay, or exposed rock. Together, arid and semi-arid regions cover roughly 1/3 of Earth's land surface, including polar regions where precipitation is extremely low. Deserts are not empty wastelands. They are systems shaped by water's absence, sudden moments of water's return, and the remarkable ways landscapes and living things adapt to extremes. The key to understanding deserts is that dryness controls everything. Low precipitation means fewer plants, and fewer plants means the ground is more exposed. In wetter places, roots hold soil together, leaves soften the impact of raindrops, and vegetation slows wind near the surface. In deserts, that protection is limited or absent. Bare ground is easier for wind to scour and easier for sudden rain to cut into. This process, called denudation, gradually strips and reshapes the surface. Because deserts can be classified in several ways, not all deserts look alike. Scientists may group them by rainfall, temperature, location, or the processes that created them. A hot subtropical desert, a coastal desert, a rain-shadow desert, and a polar desert can feel completely different, yet all share the same basic environmental challenge. Water arrives too rarely or too unpredictably to support dense vegetation. Deserts are often born from climate patterns, but their visible surfaces are sculpted by weathering. One of the most powerful forces is the large temperature swing between day and night. In many deserts, rocks heat up intensely during the day and cool rapidly after sunset. This repeated expansion and contraction stresses the rock. Over time, cracks widen, pieces break away, and once solid surfaces become fragments, rubble, and gravel. Rain is rare, but when it does fall, it can intensify this breakdown. Water hitting hot rock can contribute to sudden cracking, and short violent storms can move loose material with surprising force. The desert may seem still on a normal day, but over long periods it is constantly being broken, sorted, shifted, and exposed by heat, cold, wind, and occasional water. Rainfall in deserts is unusual not just because it is rare, but because it can arrive all at once. A landscape that may wait months or years for rain can suddenly receive a downpour powerful enough to create flash floods. Since the ground is often hard, dry, crusted, or sparsely vegetated, water may not soak in quickly. Instead, it rushes across the surface, carving channels, filling low basins, and carrying sediment. Temporary lakes can form where water collects, only to disappear as evaporation takes over. When those waters dry, they may leave behind salt pans, pale flats that record the minerals once dissolved in the water. This is one of the paradoxes of deserts. Water is rare, yet some of the most dramatic desert landforms are created by water arriving violently and vanishing quickly. Wind is one of the desert's great organizing forces. With little vegetation to block it, wind can pick up fine dust and sand and carry them across huge distances. Tiny particles may remain airborne for long periods, forming dust storms that can darken skies and move material far beyond the desert itself. Larger sand grains travel closer to the ground, bouncing and scraping against surfaces. When wind-blown grains strike rocks, they act like natural sandpaper, slowly abrading and smoothing exposed surfaces. Wind does not simply destroy, it sorts. It removes fine material from some places and deposits it in others. Over time, this sorting creates distinct desert textures, sheets of sand, dunes, gravel plains, and bare, stony surfaces where the finer particles have been stripped away. Sand dunes are the most iconic desert landform, but they form only where enough loose sand is available and wind patterns can move it. A dune is not just a pile of sand, it is a moving structure shaped by airflow, grain size, and obstacles. Wind pushes grains up one side until they slide down the steeper face, allowing the dune to slowly migrate. Some deserts contain broad, level sheets of sand, while others build large billowing dunes that can dominate the horizon. Yet many deserts are not sandy at all. In stony deserts, wind has removed finer particles and left behind a surface of smooth stones called desert pavement. These pavements can be surprisingly stable, forming a protective mosaic that slows further erosion once the loose material has been carried away. Desert landscapes often preserve signs of older, wetter times. Exposed bedrock, clay deposits, dry channels, and salt basins can reveal that water once flowed across places that are now dry for most of the year. Some clays were deposited by ancient or temporary water bodies. Rock outcrops stand as resistant remnants while softer materials around them are worn away. Beneath the surface, water can still exist in aquifers, slowly stored underground from past rainfall or distant recharge zones. Where groundwater reaches the surface through springs or seepages, oases may form. An oasis is more than a patch of greenery, it is a biological and human lifeline. It shows that in deserts, water may be hidden, delayed, or localized rather than completely absent. Plants in deserts survive by treating water as a rare investment. Many reduce water loss with small leaves, no leaves, thick waxy cuticles, or spines. Spines can also discourage animals from eating valuable water-storing tissues. Some plants grow slowly and persist for years, using deep or widespread root systems to reach underground moisture or capture brief rains over a large area. Others use the opposite strategy. Annual desert plants may remain as seeds through long dry periods, then germinate quickly after rainfall. Within weeks, they can sprout, flower, produce seeds, and die before the soil dries again. This means a desert that looks barren can suddenly bloom when conditions are right. The vegetation is not absent, it is timed, armored, and engineered around uncertainty. Desert animals face the same problem from a different angle: how to stay alive without overheating or losing too much water. Many avoid daytime heat by being nocturnal, sheltering underground, resting in shade, or becoming active only during cooler hours. Water conservation is often extreme. Some animals get much of the moisture they need from food, while others produce highly concentrated urine to reduce water loss. Dormancy is another powerful strategy. Certain animals can remain inactive through harsh dry periods, lowering their energy needs until rain returns. When conditions briefly improve, they may emerge, feed, mate, and reproduce rapidly. Desert life is therefore often hidden, timed, and opportunistic. The apparent emptiness of the landscape can conceal a community waiting for the right moment. Humans have lived with deserts for thousands of years, but survival has required mobility, knowledge, and careful use of limited resources. Nomadic peoples moved herds and flocks to wherever grazing became available, following seasonal or unpredictable patterns rather than staying fixed in one exhausted place. Oases allowed more settled communities to develop, supporting agriculture, rest stops, and trade hubs. Across deserts such as the Sahara, routes connected distant regions through caravan travel. Camels became essential because they could endure long dry journeys and carry heavy loads. These routes moved salt, gold, ivory, and other goods, but they also carried darker histories, including the forced movement of enslaved people. Deserts were barriers, but they were also corridors linking economies and cultures. Modern attempts to use desert and semi-arid land show both possibility and risk. Farming can be done with irrigation, as seen in places like California's Imperial Valley, where imported water helped turn barren land into productive fields. But irrigation is not magic. It depends on water sources that may be distant, limited, or politically contested. Cultivating semi-arid land can also expose soil to erosion, especially when vegetation is removed and the surface is disturbed. If land is overused, poorly irrigated, or stripped of protective cover, desertification can increase, expanding desert-like conditions into vulnerable regions. This does not mean deserts cannot support human activity. It means that in dry lands, every intervention must respect the tight balance between soil, water, vegetation, and climate. Deserts are also becoming important in future energy and resource discussions. Mineral extraction already takes place in many arid regions, because exposed geology can make deposits accessible and because sparse vegetation may make exploration easier. The same clear skies and intense sunlight that make deserts difficult for life also create enormous potential for solar energy. Vast open areas with uninterrupted sunshine can generate power at impressive scales. But even here, deserts should not be treated as empty space. They contain fragile surfaces, specialized ecosystems, cultural histories, groundwater systems, and communities that depend on them. The real lesson of deserts is not that they are lifeless. It is that life, geology, and human ambition all become sharper and more visible where water is scarce. If you found this helpful, please like this video and subscribe for more explainers.